So let's get started. Hello, everyone. I'm Mengyi from Supermap. I'm Mengyi, training engineer from Supermap. And today we will have a lecture on land use evaluation promoted by GIS model. And the content will be divided into 4 parts. First, we will explain the importance of land use evaluation. And in the second part, we will have an overview on the general framework we use for land use evaluation and the factors involved in the process. And in the third part, we will have a detailed discussion on what kind of GIS technologies are used in land use evaluation and how can we use GIS model to enhance the whole process. And finally, we will have a quick discussion on the application prospect of GIS model in sustainable development. And to begin with, let's first talk about why should we take land use evaluation and what's its significance. So during the development of human society, environmental issues has emerged as the consequence of misuse of natural resources. And now countries and organizations all over the world are trying to tackle these problems by using new environmental strategies and negotiations. So in 2015, the United Nations has promoted 17 sustainable development goals. And among them, there are some concerned about climate change and environmental protection. And here is a list for the 4 goals concerned about environmental issues. And from these highlights, we can see that it is obvious that the key to achieve these sustainable goals is the proper management and allocation of natural and ecological resources. So these resources we care about all rely on land, and land provides a space for these resources. So the way we use the land will have a direct influence on the resources rely on land. So in order to make a reasonable use of land, we need to thoroughly plan how to use the land based on a comprehensive knowledge of what resources we have in that space. And such decision-making process is called land use evaluation. And this is a premise for the realization of sustainable development goals. And so what do we need to know about our land space? For instance, we need to survey the exact amount and quality of land we have in an area, and thus to calculate its productivity and plan how to use the resources on the land to a proper extent. And also during the evaluation process, we need to keep in mind that those natural resources and social resources and that both natural resources and the environmental resources and social resources are equally important during the evaluation. And moreover, according to our sustainable development goals, we need to find out problems related to our current land use type and therefore find solutions for them. And so in the second part, we will have a quick introduction on the general framework and factors we use for land use evaluation. And when we consider about the process of land use evaluation, the first question come to mind might be this one: how to evaluate the land? So there are many countries and organizations has promoted their frameworks for land use evaluation. For instance, the United Nations has brought forward a land stability evaluation framework in 1980s, and in this evaluation framework, the evaluation result will be divided into 2 categories: suitable or not suitable. And these categories are evaluated based on these based on these basic evaluated units. And in the US, the Department of Agriculture has proposed a evaluation framework to determine the agricultural value of a certain area from two aspects. The first one is the quality of land itself, and the second one is the location of the site. And in recent years, China has adopted a new way to evaluate our land. This is a two criteria evaluation framework, and it can determine the value of land on the use like ecosystem protection, agricultural production, and urban planning. And from these frameworks, we can summarize that the general structure of land use evaluation framework can be divided into three parts: land use evaluation factor, evaluation criteria, and evaluation logic. Evaluation factors are the basic elements we use for the description and judgment of a land. And no matter what framework we used in the evaluation, the way we describe a land is always the same. And evaluation criteria is a guidance for us to grade the value of factors into several classes for further evaluation. And the evaluation logic is a key for each evaluation framework. And also it is the main differences between frameworks. It gave us a way to combine the classified factors together and in order to produce our final evaluation result. And so we can see that among these three parts, the evaluation criteria and evaluation logic are varied based on the evaluation framework we choose and the local condition of our specific case. But the evaluation factors we used are always the same or similar for a specific type of land use. So really, we will describe a land from these three aspects: land capability, environmental impact, and socio-economic feasibility. Here, land capability refers to the property of land itself, like terrain, soil type, and its resilience to hazards. And the environmental impact is the influence of a land on its resources and surrounding areas under certain type of use, like transforming a piece of land near forest into an industrial area could have significantly negative impact on the local waters and air quality. And socioeconomic feasibility concerns on the location of the land to significant social and economic resources, such as the proximity to a highway network and the distance to big supermarkets. So in the real practice of land use evaluation, we will select our evaluation factors from these three aspects based on the exact type of use and the local conditions. And now we will have a detailed discussion about GIS technology we used for land use evaluation and the model, and how can we use the model to promote the whole process of evaluation. So as we discussed before, after we collected the original data for land use evaluation, we need to calculate our evaluation factors out of this data, and then we are going to grade these factors based on the evaluation criteria. And after all the factors are classified according to our evaluation criteria, we will follow the evaluation logic to combine these classified factors together and get our final evaluation result. And GIS technology is able to implement the whole process. Like for the data part, traditional GIS data like DEM, remote sensing image, and vector files contains the basic spatial information we need for land use evaluation. And after we get the data, we can use spatial analysis tools like slope analysis to transform the original data into the factors we need for our evaluation process. And then the tool called raster reclassify is the exact tool we need to grade the values of our evaluation factors. And finally, as the combination of factors, the sort of factor combination is similar to the sort of multi-criteria analysis in GIS. So we can use raster algebraic as a method to combine all the classified factors together and get our evaluation result. And therefore, we can summarize the GIS operations we take in GIS software for land use evaluation into this 4-part flow work. The first part is data processing, and then it's spatial analysis to calculate the evaluation factors, and then it's reclassification. After reclassification, we can use raster algebraic to get our final result. And in the actual practice of land use evaluation project, the algorithms and tools we used for the first two steps are varied due to the variation in data format we use and the data excuse me and the evaluation factor we selected. And for the third and fourth part, the tool we used for analysis and processing are always the same, but the parameters, expressions, and weights we set for the calculation are varied according to the evaluation framework we use and the evaluation criteria we designed based on local conditions. And as these 4 parts flow work are highly generalized, we need to realize that actually for each of the part we might need to use multiple tools to get the result we want. For instance, for spatial analysis, maybe we need to use 3 or 4 tools to calculate one factor, and there are more than one factors we need to calculate. And after we get all the factors, we need to reclassify all of them and before. And so there might be a concern about if we have enough tools in our GIS software to support all the process we need to take. And if we choose Supermap iDesktop X, we don't have to worry about this problem, as this software provides us with around 800 GIS processing and analysis tools to choose from. So it can support us to complete the whole process of land use evaluation. But there's another question come to our mind. In actual evaluation project, usually we won't evaluate just one piece of land. We will have multiple areas to be evaluated under the same criteria and evaluation frameworks. But we have to repeat this whole process again and again for each of the area. And every time we're going through this process, we need to use the same type of tools and set their parameters every time we use that tool. And this is kind of tedious. So here we might So here we need a new kind of tool that could conduct this whole process automatically for us and produce the result we want. And the tool we are looking for, the model can automatically execute to produce the result as we design the flow work and parameters for each tool in that model. So here we will have a demonstration about how to build a geoprocessing automation tools in SuperMap iDesktop X. Here we can find from the right, on the right is our toolbox, and we can choose our geoprocessing tools from it and drag it to the window in the center. And by clicking the blue rectangular here, we can set the input data and parameters for each of this tool. And the green ellipse followed is the output for that tool. And this output could work as the input for the next tool. And the tools are connected by these line arrows. So in this way, we can build a process. So in this way, we can following our processing flow work to create this model. And after we created it and set the parameters and input data for it, it can automatically work for us and spare our time for repeated operations. And so now let's have a thorough discussion about how to apply GIS model in land use evaluation. As we have discussed before, factors are the basic elements for the judgment and description of the land. So here we can create submodels to calculate one factors and reclassify its value according to the evaluation criteria. And this is an example of the submodel we created for terrain factors and for terrain factor. And we can create submodels for each of these factors, and the result of our submodel is the classified factor. So after we create submodels for each of these factors, the result we get are the classified factors according to our criteria. Our next step is to combine these classified criteria based according to our evaluation logic. And really, we will complete this step using raster algebraic. And in this process, the weights and expressions we use for our calculation, the weights and expressions we used for the calculation is the mathematical interpretation of the evaluation logic. And after we set the correct weight and expressions, we can get our calculation result, which is the evaluation result for this model. And so create submodel for each of the evaluation factor, and then combine them according to the evaluation criteria and get our final result. A GIS model integrated with all of these is a comprehensive model for land use evaluation. And also, as we said before, the factors, no matter which evaluation criteria we choose, the factors we used to describe and evaluate a land is always the same. So once we created a submodel for a specific evaluation factor, this submodel can be used in different evaluation frameworks, as long as we change its parameters based on the evaluation criteria for the specific project. And now we will have see some examples of GIS model applied in land use evaluation. So our first model is to use a global DM data to evaluate the terrain for the globe. And the DM data is in 90 meters. It is shown as the finger on the left and the finger on the right. And so the factors we choose for evaluation are slope, height, and aspect. And this is our evaluation framework. Here we need to notice that our DM data for the whole globe are stored in multiple pieces. So if we're going to complete this flow work by hand, we need to go through this process for each of the DM data piece. And this will take a lot of time and energy for us. So the better way to do it is to create a model for this data processing flow work and take batch processing as we use the DM data as an input, and finally get the evaluation output like these fingers on the bottom right. So this is the model we created for the terrain evaluation. Here are the tools we used to calculate slope and aspect values. And after we get the values, we use raster reclassify to reclass the value of slope, height, and aspect. And then we use raster algebraic to combine them together. And after the evaluation, we can get the final terrain evaluation result for the whole globe. And here we can see that the model can take in multiple pieces of DM data to take batch processing, which saved the time for us. But the structure of this model is quite simple, as it only evaluates the terrain factors. So we can save this model, and after saving it, we can use it as a sub-model in a more complicated evaluation system in the future. So it will again save our time for the evaluation process. And our second instance is a more complicated evaluation process. The goal for this process is to evaluate the agricultural capability of 2 cities in China. And the cities involved are Chongqing and Qingdao. Here we can see that these are the evaluation factors we choose to calculate the agricultural capability for our study area. And so we need to create some models for each of these factors. And here, for the terrain factor we're going to evaluate, we can use the submodels for it. We can directly use the model we created in previous instance as a submodel for the terrain factor in this case, and then change the parameters for it as the criteria for our evaluation may be different. And then we can create submodels for each of these evaluation factors. And after that, we can use raster algebraic to set the expressions and weights to combine these factors together and calculate the final agricultural capability result. So after the model is built, we can put in the original data of Chongqing and Qingdao respectively, and the model can automatically execute. And after that, we can get the output. The output we get from the model is the agricultural capability evaluation result for the 2 cities respectively, and the evaluation factors generated in the middle can also, and we can also check the evaluation factors generated in the middle, and to get more information about the 2 cities. And another way to apply GIS model in land use evaluation is to take the same set of data as our input for different evaluation models. Like here, we have the models for agricultural stability evaluation, ecosystem protection evaluation, and urban planning suitability evaluation. We will use the data for the same area as an input for the stream model. And then the stream model will give us the evaluation result for the same area under different type of use. And as we immediately get the evaluation result for the three type of use, we can compare them and choose the best land use type for this area. And so from these examples, we can find that the creation of GIS model is quite simple, and the ability of GIS model to automatically process data and to automatically execute it and generate data for us has significantly increased the efficiency of improved the efficiency of data processing and analysis. And also as there are changeable parameters in the model, and we can save sub-models for future use, it adds more flexibility to this tool. So we would recommend to use GIS model for land use evaluation. And finally, we will discuss the application of GIS model in the field of sustainable development. As we have discussed before, the GIS processing model is suitable for cases where we have standardized flow work for data processing and analysis, and repeated operations are required to deal with batch data, and the variation during the process mainly lies in the data and parameters we use and the parameters we used. So in this process, in the research of sustainable development, there are some subjects like disaster effect analysis, land use change model monitoring, and the project environmental impact assessment. This subject has a standardized workflow for data processing and analysis. So it seemed to us it is a smart way to apply GIS modeling GIS model into these projects to improve our data processing efficiency. However, we need to consider that in this process, in these projects, the data we used are much larger than in land use evaluation project. And also the algorithms and analysis methods we used are more complicated. In this situation, is GIS model still a capable method for us? Is stable in such cases, is GIS modeling still a capable method for data processing? And that's what we should consider. And for this question, the answer actually is yes, because our GIS model is not only able to combine traditional spatial analysis tools together, it can also integrate with big data and streaming data. And after that, it can process them with methods like distributed computation, GeoAI, and blockchain. So these abilities make GIS model powerful enough to complete the work of sophisticated projects. And therefore, when we're dealing with, doing with researchers in sustainable development, and there are big data and streaming data involved, do not hesitate. We can still use GIS model to improve the efficiency of our work, improve the data processing efficiency of our work. And that's it. Thank you.